Alright, so let's look at number 1 again real quickly, just to talk about it a bit more. On 1, we had done it in class, and I was going to show you this on the graph. This is the line y equals 3. I'm actually creating a new axis just to let you see what's happening with the sine wave. Alright, now I'm going to then go to draw. So I want to do a line from negative, let's see, where do I want the line? I want the line at pi over 4. So I'm going to say pi over 4, comma, negative 10 to pi over 4, comma, positive 10. That should draw me a vertical line right here. Oh, gotta hit enter. Okay, so please notice this axis. In fact, I can turn this axis off. I'm going to ignore the yellow. We're looking at the blue and red at that new axis. In fact, I can even change this to blue, but I'm just going to leave it. All right, now I'm going to turn on the graph, and we're going to watch it graph at our new axis. And I'm going to go to Window. You don't have to be able to do any of this. I'm going to go to Format, and I think I can turn the axis off. No, we'll make it white. Maybe we won't see it that way. Or there, it's off. All right, now I think I've got to put the line in again. So I've created a phase shift and a vertical translation for you. So this is up 3 and over pi over 4 for my new target. Oh, let me get it, sorry. Enter. Okay. Then here comes our graph. Okay. And you can see how we have a negative sine wave coming through here. Now this is really actually the 0, 0 was down here, and we've moved over pi over 4 and up 3 and done our negative sine wave. So that's why it's called translation of the axes. All right, we won't do that fancy stuff anymore. I'm going to do just a few more problems for you. Please carefully check the assignments page. This won't last long, so I'm just going to speed on through. All right, we're using same slides. We'll go to these. All right, so I'm going to do number 2. Right, I know there's a 1, 2, 3, 4, 5, so make sure on each side, so make sure you're looking at this number 2 that I'm going to be doing. Y is equal to 2 plus 4 cosine of 2x minus pi. In class, I pointed out there's a 3 hanging off the end. I didn't intend for it to be there. This is plus. All right, the amplitude is 4. The period is 2 pi over 2, or pi. I divide that into 4 equal parts, and I'm going to count by pi over 4. When it was easy, last video I sent you, we were just counting pi over 4 from 0, but now we have a phase shift. So set this equal to 0, the whole thing. And if you solve, you get pi over 2. So our phase shift is pi over 2, and our vertical translation is up to 2 plus. This is my new 0, 0, for lack of a better word. This is my new starting point. I'm going to go over to pi over 2 and up 2. I may have done this one in class, but I'll finish it. I've gotten this far. I think I did do this one. But I may not have been videoing. All right, so this is my new target. I'm not concerned about this anymore. I'm looking over here. All of my thoughts are over here and actions. All right, now if this is my new target, if it's sine, I'm going to put my dot there. But if it's cosine, you actually put it up, above 4, and down 4 of this axis. Yes, and now I remember I did do this one, so I'll hurry up. So from here, I'm going to go up 1, 2, 3, 4, and put my first cosine dot, because it's a positive cosine. Oh, and I didn't label my axis. I'll do that in just a minute. I need 4 marks. The reason I made them that size is I'm counting by pi over 4. Start counting to your phase shift. Add to your phase shift. So I have pi over 2. I'm going to change that to 2 pi over 4 so that I can add pi over 4. So this is 3 pi over 4, 4 pi over 4, 5 pi over 4, and 6 pi over 4. You can verify that I actually have marked off a chunk of time of pi. Alright, so it's a cosine graph dot here. At the next mark, it hits the middle, the average, the midline. Here, it goes down to -2. Here it comes back. And so you're getting this graph that looks like this. When you graph 2 periods, I usually want you to go backwards or forwards to cross the axis just so it looks a little more normal. So go back by the same units you were counting with by pi over 4s. This is 2 pi over 4 minus pi over 4 is pi over 4. Comes back to the middle. Pi over 4 minus pi over 4 is 0. And so at that point it's low. And then it keeps going like this. So label a line of it. Just for argument's sake, let's check what happens at 0, when x is 0. When x is 0, this is gone. Cosine of negative pi is -1. So you have 4 times -1. And 2 minus 4 gives you -2. So you can see that these really are a tricky way to get all of those points. All right, let's go quickly to number 3. All right, number 3, on that page we have 5 cosine 3x minus pi plus 4. All right, so the amplitude is the number in the front multiplied is 5. The period is 2 pi over 3. I'm going to count. I'm going to multiply that by 1/4. And that gives me count by pi over 6s. And from where? My phase shift and vertical translation. By the way, when we had problems like this on Delta Math and for your homework, just these, your phase shift and vertical translation were just 0. So you were adding pi over 6, 2 pi over 6, and so on. But now we need to know our new target, our new starting point, because this graph will shift over and up. So I have 3x minus pi to get my phase shift equals 0. So I'm going to shift over pi over 3. And my vertical translation is positive 4. Okay, going to kind of start to think pi over 6 is half of pi over 3. So I'm going to move out here, and I'm going to call this pi over 3. I'm going to call it 2 pi over 6. Plus pi over 6 is 3 pi over 6, or you could reduce to pi over 2. 4 pi over 6, you could reduce to 2 pi over 3. 5 pi over 6, 6 pi over 6. So I'm reflecting the fact that this is half as big as that first mark that I made right here. Also, you can verify that the period of this is going from pi over 3 to pi, which is 2/3 of pi, which is the period of time it should take to complete the graph. Alright, so I'm moving over pi over 3 and up 4. This is your new starting place. 1, 2, 3, 4. And so my new target's right here. I'm focusing all of my attention here. If it's a sine wave, I'll put the dot right on my new target. But once again, it's cosine. So with cosine, I'm going to start with positive. I'm going to go up 5. Need to mark that off real clearly. 1, 2, 3, 4, 5. So my first dot's here. then it's going to go to the middle, then it's going to go down 5, back to the middle, and back up high. And it continues on like this. Make it real curvy, it goes like that. One thing that we were talking about in class, the highest it can go from 4 is 5 units up to 9, and the lowest it can go from 4 is it can wave down 5 to -1, so it helps you know if you got your amplitude right based on your midline. All right, number 4. Oh, sorry, we'll just have a plain page. Number 4, I changed it. So if you haven't looked at the new document, I changed it to 2x plus pi. I changed it to a plus because I didn't have any that were shifting the other way. Amplitude is 5. I see a negative in front of it, but it's just going up and down 5. The negative will help me with the direction. The period is 2 pi over 2, or pi. Count here is easy, pi over 4. Let's find our phase shift. 2x plus pi equals 0. 2x equals -pi. X is -pi over 2. So my phase shift that I start counting from is -pi over 2. I'm going to start adding this to that, and it's going to move up +2. It can move up or down. I tend to do a lot of them going up. All right, so I start here at -pi over 2, 2. Focusing all of my attention right here. This is the midline. It'll fluctuate up and down from there. All right, got another cosine wave. Boy, I got a lot of cosines on this page. If it was sine, I'd put my dot right on the new origin, the new starting place. But it is cosine, and it's a negative cosine. So the first thing I do is go down 5. So I'm going to mark those units off. 1, 2, 3, 4, 5. And it's a really cool thing about cosine. Really cool thing about cosine is you can tell where your first dot should be if you add or subtract those numbers. 2 minus 5 is -3. Oh, I did never count, sorry. This is -2 pi over 4. If I add pi over 4, I get -pi over 4, 0, pi over 4, 2 pi over 4. You can verify once again that this period is pi over 2 in either direction. So I have low, middle, I go up 1, 2, 3, 4, 5, back down to the middle. One thing we'll talk about in the next class, some of you might notice there's another way to write this equation as a positive cosine wave that just starts right there. But we'll talk about that later. Okay, now let's go to number 5. We'll go back to one of these. All right, so let's see if there's any more of these down here. Yeah. Oh, we've got this cool thing. Okay, so number 5. You have y is equal to 5. I'm sorry, it's another cosine, pi x minus 7. All right, so don't forget those links under topics that also I showed you, and I didn't record at that time, but you'll see it under graphing trig functions on the topics if you needed to look up more because I'm moving pretty fast. Amplitude is 5. Period is 2 pi over the number in front of x, which right now is pi. So you don't even have to have you can have a rational number. John, anything? Now I'm going to see what to count by. So I'm just going to be really literal and do what I've learned. I'm going to divide that 2 into 4 equal parts. So I'm going to count by halves. And so it's kind of weird, isn't it? Interesting now that it feels kind of funny that we have an integer instead of an irrational number. Phase shift, there is no phase shift. Nothing's added or subtracted to that, so it's not shifted over. But my vertical translation, it is going down 7. So this is my new target right here. Okay. I'm going to count from 0 by halves. 1/2, 2 halves, 3 halves, 4 halves. And if it was a sine wave, I would put my first dot right here. But once again, I have cosine. And so my first dot goes to positive 5 above that. And so my first dot goes to negative 2. 5 and negative 7 gives me negative 2. That's as high as it'll go. And then at 1/2 it goes to the middle. And then it goes below this line, 5 units, 1, 2, 3, 4, 5. And back up again. And so the whole thing is below this. And on your homework, if you do 2 periods, you would just keep counting out by halves and draw some more points. Okay, so now so that's the whole first page. You've got the second page again. Make sure you check the document and assignments for the update. I'm going to show you real quickly, and we'll talk about it more in class, how to graph secant and cosecant. This is great news. What would happen if I wanted to graph cosecant of this same thing? Negative 4 times 1 over sine of 4x minus pi plus 3. Do you see I just took the reciprocal of the other graph? This one is actually cosecant. And so I just said 1 over sine. I need another parentheses. You always got to make sure that you put what you mean inside the parentheses. The plus 3 is off the end. This right here is just my vertical translation. I'll just leave it in there. All right, I'm going to do something kind of fancy with this. And by the way, I don't hardly have any students that I'm sorry, I was trying to get the line to change. I don't hardly have any students that, I'll get it in just a minute. Okay, that's what I want. All right. Sorry, what I was going to say is I hardly have any students that ever type cosecant or secant or cotangent into their calculators. All right, so here's the midline. Look what's happening. So that's why secant and cosecant are so easy. It is literally the reciprocals of those numbers. They meet at their amplitudes, and then while these numbers are getting smaller, you can think of the reciprocals are getting bigger. When this number is hitting the midline, it's sort of like it's hitting its new zero, and so the other one, the opposite of that, is going off to infinity. So this is how easy it would be, starting in the next class, to graph. Suppose that we were told to graph, just suppose that we were told to graph y equals 5 secant pi x minus 7. Notice the minus 7 is not in parentheses, so it's off by itself. It's like negative 7 plus 5 secant x, pi x. All right, now, whenever I tell you to graph secant or cosecant, then just graph its reciprocal first, dotted in like this. So let's graph cosine, which we already figured out over here. And so I would dot it in like this. And get a lot of it going. The reason it's dotted is nobody asked me to graph cosine, so it's sort of like an asymptote, but it's not a line. Everywhere it hits the midline, it'll go off to infinity. Everywhere it hits the midline, you draw those. And then you meet at the height of the amplitude and stay within, follow your asymptotes. You get these funny U shapes. And so everywhere that cosine goes, secant does not, because they're reciprocals of each other. While it's getting smaller, its reciprocal's getting bigger. And the only points they share are those ones at their amplitude, which we can talk about why later. So to graph, see if I got any more slides. To graph cosecant later, when we start that on Thursday, wherever your midline and your phase shift are, you would draw a sine wave, get a little bit of it going. Everywhere it touches the midline, you'll have an asymptote. Reciprocal of 0 is undefined, infinity. And then meet it at the amplitude and stay between your lines. And you would get the graph. That's all you need to do for cosecant and secant. Just graph their reciprocals and then stay within the lines. I would count off if you draw it really skinny or too skinny or too fat or whatever, because those lines dictate the width of it, so follow your asymptotes. There's something else I want to say before we quit, and I can't remember what it is. Oh, some people don't actually even dot it in. Let's say if you're graphing cosecant and you're using sine as a pattern, some people just go, oh, sine would start here and go high, middle, low, middle. And so they don't really ever have the dotted line in here, and it's just less messy. But that's up to you. And so at the high and the low, it meets like this. And at the zeros, it has asymptotes.